This is the second scenario. So the first scenario was on cloud and edge 6G red teaming. This is a red teaming of the AI supply chain risk analysis. That's the purpose of this scenario, and we're looking at distributed AI and machine learning in 6G environments. We're gonna run 3 scenarios. This is the second one. The third one is gonna come in a separate video because it takes a little bit long to go through all these steps. And this scenario is a little bit more detailed than the first one. As you can see, the first one was kind of ending around here. With this scenario, we have a table expanded and more steps, just because the complexity it's bigger on this specific topic for red teaming. So when you're trying to look at the supply chain risk analysis, the range expands. It becomes much bigger than, for example, just a specific one unique model. So supply chain is it has more problems. And as with the last video, first I'm gonna explain the diagram, then I'm gonna move to the whiteboard and I'm gonna be drawing and explaining the individual steps of those diagrams. But I'm not gonna be going through the steps with this screen, because I have a pen and pencil on my iPad, so I can use as a whiteboard. It's gonna make more sense that way. Just to look at what are the expected outcomes of this specific exercise. We're looking at understanding the risk of tainted AI models in a distributed AI machine learning supply chain for 6G. Distributed decentralization is one form of distributed computing. There's other forms of distributed computing. And my main area of specialization is decentralized AI, when it doesn't have a central point of failure. But here we're looking more at distributed AI machine learning, not only decentralized. For this, we're going to apply the STRIDE and supply chain threat modeling techniques to AI components. I'm going to go through what is STRIDE. STRIDE is one of the frameworks for supply chain risk analysis scenarios and any form of AI scenario analysis. But it's more useful, in my opinion, for AI supply chain risk scenarios. And we can also be looking at developing layered mitigation strategies that they are spanning the pre-deployment and runtime validation. As with any decent red teaming exercise, you start with a problem, you create a scenario, and based on that scenario, you come up with different problems and you try to resolve those problems, and you come up with solutions for those problems. These scenarios are based on how the MITRE ATT&CK and the MITRE ATLAS frameworks are structured. So you have a problem and you have a solution for that problem. So for each step of these boxes over here, I'm going to be coming up with a specific solutions that you can implement to resolve those problems. The difference between this scenario building with red AI teaming and MITRE ATLAS is that MITRE ATLAS refers to technologies that they exist. And as you can see here, 6G environments, they don't exist. There's no actual testbed anywhere in the world using 6G environments. There are very good 5G testbeds, but your iPhone has 5G connectivity. Most of the devices that we use now have 5G connectivity that has been tested extensively. So this is not covering that. This is looking at the next version of this technology, bigger speed and all those advantages that they have with the next generation of the internet. And it's definitely coming. We had 4G, then we have 5G, and it's natural that we're going to have 6G. What are the specific characteristics of that 6G environment? Well, we'll see over here. Now, this is the scenario. Let's go through we have a red teaming exercise. Then we have characteristics of that specific red teaming exercise. We have the topic of the red teaming exercise, and we have steps that we're going to be performing. Then we have clarifications on those steps on how to perform them. But obviously I'm going to be drawing. This is a very basic drawing tool that I have here. So with this tool, for example, if I try to explain something on step 3 or 4, it's going to be very difficult to draw on my mousepad. That's why I'm going to switch off. I'm going to close the screen, and I'm going to screen share my iPad. And now you should be able to see the same diagram, but on the iPad. And the beauty on the iPad is that we have far better functionality of this pen that I'm using. So let's start with the blue pen here. Let's use the maximum and see if that is going to be good enough for us. Now, as with the scenario 1 on cloud, even with scenario 2 on distributed AI machine learning in 6G environments, I'm going to be explaining the steps, and then after each step has been explained, I'm going to tell you why those steps are crucial. But maybe the preference is to do it differently, to start with why those steps are required, then to list the steps. But this flow makes more sense to me because you're seeing what is happening and then you realize why is it happening, as opposed to I spend a lot of time thinking about why those specific steps need to happen. So that's that part can take much longer. But when you list the actual scenario and then you cover it, I think that's faster, as opposed to going through my whole chain of thinking as about why specific technology is included in there. With the last scenario on cloud technology, I explained that decentralization is going to be a key component. Federated learning in that environment is going to be a key expected component, and how I extracted all that from existing literature, world-leading literature on this specific topic. So many of these scenario designs, one of my very recent scenario designs included 750 research papers, review of 750 research papers to build the scenario. So they are not designed by me. I had to consult the world, the experts of the world, and build the scenario. So this is the scenario. How does it start? First, you have, let's say, a trained model artifact in distributed AI pipeline for 6G networks. So this is the simulation. So you have tainted, infected, maliciously tampered. And in this fully virtualized and disaggregated 6G network, multiple third-party vendors contribute with AI and machine learning components for dynamic network slicing. So you have energy-aware resource optimization and predictive maintenance. So that is the scenario that we have, and this is the problem that we have in this scenario. So where do we start with this scenario? First, we start looking at decentralized edge data centers. We need to have centralized cloud AI services and ORAN intelligence controllers. Now, it's difficult to explain why this is the expectation, but based on existing literature that we have, centralization is the key security mechanisms that is imposed at this present moment. Doesn't mean that I agree with that. It's just I acknowledge that that's what the literature states, that centralized cloud AI services are more secure, because there's also elements of regulations and those regulatory compliances make this the only option in terms of cloud AI services. If it's decentralized edge data centers, and let's say if you use a blockchain over here, everything that's recorded on the blockchain stays recorded forever, and that's non-compliant with the GDPR. So that's why the data and the AI services, when you run the data, it's stored there. One specific example that will make it clear why this is compulsory is the right to be forgotten. Let's say you have an individual that is multiple individuals that they're funneling data to a centralized data server, and if you say this individual says I have the right to be forgotten, erase me from this database, that is possible with centralized data. But if you have multiple individuals going to multiple data nodes like the blockchain, it's difficult because you don't have control over that. That is an independent node based in some country far away that you have no rights over it. You won't even be able, there's no communication mechanisms, first of all. So they have validated that, and they're moving on to another one. But you can have decentralized edge data centers. So this is the edge data. And what does it mean, decentralized data center? Well, that's basically like a gateway. So gateway with multiple entry points that they are entering there, but then that data is still fed into a centralized data point. So this is a pre-filtering, so to speak, when privacy is preserved but not damaged. Let's say you have this data center that is only recording at the edge, it's only recording one specific information and it's deleting all the other information. That means that only that specific data is fed into this centralized cloud server. Now, moving on from that, these models are deployed, let's say, in multi-vendor AI pipeline, and each AI model goes through 3 stages. So here are the 3 stages. The first one, you have initial training by external vendors. Second, you have packaging in OCI compliant containers, and third, you need to deploy them in real-time inference agents. Now, what is the problem from all of those three? Well, the AI model provenance system used for lifecycle assurance, for example, model cards, S-bombs, VEX, vulnerability explainability exchange, those are only partially enforced and lack cryptographic traceability at the edge. So that is the problem. And the red teaming scenario that we're creating here, and again, I'm going to come back and do an overview of why those things are required at the end. Now we're just doing about how scenario is being built based on existing knowledge from all the experts in the field. And here in the last scenario, we were talking about red teaming intelligence. So here we are looking at red teaming threat scenario. And in this scenario, we have a malicious actor that inserts, for example, a Trojanized AI model into the supply chain through a compromised open source model hub used by, let's say, a subcontractor. And the backdoor is activated during specific input sequence that is related to anomalous network traffic. So the scenario characteristic so over here is that the backdoor bypasses anomaly detection on malicious flows, allows lateral privilege escalations across virtual run nodes, and subverts the AI orchestration trust scoring system by feeding biased telemetry. And the breach here remains undetected for weeks due to lack of runtime model verification and weak provenance training. This is the expectation, that scenario would result with weeks of undetected verification of the provenance training. And moving on to the AI supply chain risk analysis of the distributed AI machine learning in 6G environment. How would you perform that? So this is a good moment to stop for a second and think, if you are doing it, how would you do it? Is it going to be the same like the process that I would be explaining? Because my original process was very different. When I started consulting literature and all the conferences that they have emerged in the last 12 months, the steps have changed slightly. So the first step is I'm looking at the AI supply chain mapping. So I need to map out the full AI lifecycle stages and the identity, and I need to identify these 4 key elements. The first one is the external vendors, the data suppliers, the model providers. The second one is the internal CI/CD pipelines. Third is the containerization and deployment orchestration. So for example, Kubernetes, Helm. And the fourth is the inference nodes, the edge, REC, cloud. And we need to highlight the trust boundaries and choke points. So unverified model updates, third-party SBOM gaps, model registry spoofing. Those are the things that we need to be looking in this process. So that's the step number 1 of the red teaming exercise. Step number 2, we need to perform attack simulation design. So we need to design an AI supply chain attack against the 6G orchestration layer. So how do we do that? 3 steps. First is we need to define the payload. So is it going to be poisoned model, embedded backdoor, or data trigger? Then we need to define the insertion point. It's going to be the pre-training of the data source, the model zoo upload, the container registry, or the CI/CD hook. And third step is we need to identify propagation mechanisms, for example, with the Helm charts to multiple edge zones. And once we have those 3 steps performed, when we have the attack simulation design of the supply chain against 6G orchestration layer. Now, the step number 3 is when we perform the risk assessment. And here, this table, it's cloudy because I designed it in Word, but then when you import this into Microsoft Visio, so Microsoft Word and Microsoft Visio don't have a synchronization mechanism how to insert the table. So I had to copy it and export it as a PDF, and that's why it's so cloudy here. But the asset components, here we're looking at the risk assessment. We're looking at the asset component, threat vector, vulnerability, impact, likelihood, and risk rating. So we have to have this risk rating, that the more critical or less critical, because remember, not all vulnerabilities are mitigated. If it's a very low risk and low impact, those vulnerabilities usually are not really considered as very dangerous. And what are the asset components that we're looking? So for example, for ORAN ML models, and we have the same for edge models, for AI orchestration service, and for the model provenance database. Some of the threat vectors that could be, it's tainted model with the OCI container. Threat vector could be the credential lack for model uploads. Another threat vector is compromised pipeline hook or tampered metadata. The vulnerabilities here is, for example, the lack of model signing. So, and there's no SBOM validation. There's no upload integrity checks. There's unauthenticated webhook endpoints. Unencrypted logs, no signature enforcement. So those are the vulnerabilities. If those vulnerabilities exist in our network, then we have a problem. But as we said, every vulnerability has a risk scoring and the likelihood scoring. And then there's also the impact. So how much of an impact that specific vulnerability and that specific asset threat vector will create. Well, for this one, it's a backdoor inference trust manipulation. And you need to assess the likelihood and the risk scoring for that. It's specific to the asset components that you have. And second impact could be the model poisoning, false trust propagation. And that's, again, it could lead to integrity failure of the model and various other problems. Third impact factor is the pipeline compromise, rogue updates. So if you're getting false updates, for example, and your system is not secure, that's problematic. And third and final impact factor here is the trust decay, failure to detect tampering. And that, for example, from a cybersecurity perspective is problematic, but the risk, for example, if it's high and if here you have the trust decay as low and low, then you need to focus more on areas that are critical. But this, for me, would be the main one to be looking at. Now, moving on to step 4, the mitigation brainstorm. So here, you need to have, again, experts in your organization that would be able to brainstorm what mitigation techniques are available. And I'm just including some examples of what you would be. Let's say you're one of those experts here. What kind of mitigation techniques you would be able to suggest? Well, model provenance hardening. So you can use blockchain linked attestations, signed model cards, immutable SBOM entries. You could suggest runtime model verification, so homomorphic hash verification of confidential computing enclaves. You can suggest zero trust for AI artifacts, model authentication with short-lived attestations and distributed PKI. Or you could even suggest red team playbook, includes supply chain checkpoints in CI/CD simulation, design poisoning, detection, fuzzing stages. And things like this one, for example, are always fail-safe. So whatever people opinion they have, with red teaming playbooks, you can never go wrong. So that is also very safe. When you suggest blockchain usage, be careful, because some people really don't like blockchain and they don't see the value of blockchain. Obviously, every technology has its own pros and cons. So I'm not going to go into politics about is the blockchain the best technology ever. But in terms of GDPR, blockchain is problematic because you cannot erase the data. Step 5, testing. So in the testing, what are the questions that you need to address during this testing? So if you're sitting in a room, okay, you think, like, how do I test? What am I actually testing? And one question is, and this is how example of how you can word your questions, what would it take for users to trust an AI model trained by a third-party vendor deployed across 6G infrastructure? And under what conditions? So you can build a trust framework here for accepting or rejecting external models in distributed AI pipeline for 6G machine learning. One thing you could say is it needs to have secure multi-party computation. And what is secure multi-party computation? Let's say you have, this is the cloud and this is where AI is happening, and you have multiple, usually the example is used with hospital 1, hospital 2, hospital 3, hospital 4, hospital N, hospital 5000 maybe, and they want to share data on patients with specific illness, but they don't want to share the data between themselves. Because that would expose risks of patient privacy, so that is not acceptable. What they do, they share the data with a specific secure multi-party computation, where each one is sharing specific information, and that information is not fed directly back to hospitals, but the aggregate is so the results, the outcome is shared. So you can say that they have to apply secure multi-party computation. They have to apply differential privacy in training. Again, differential privacy, which we'll cover more, is, let's say you have data points here, and then you want to change that into something that you add noise to those. And the more noise you add, the less useful they are, but that's your data privacy budget. And maybe those would change slightly but the actual pattern would remain. So that's differential privacy. You can say you need to have this differential privacy. Another thing you can say, you need to have federated audit trails, and you need to have SBOM VEX informants with runtime monitoring. Now, that concludes the scenario, but now let's just have a brief overview of the scenario before we move on to the final scenario. What should I use? Yellow. Let me use, no, that one, not this one. Yellow pen. Let me change a little bit here. So here, when we're looking at AI supply chain risk scenarios, we're specific to threat modeling in distributed AI and machine learning environments. What do you learn from scenarios like this? Well, this specific scenario explains the complexity of modern AI pipelines, and it helps you understand how the model risks at the intersection of AI and supply chain are linking to distributed 6G infrastructure. And one of the most pressing emerging threats in 6G infrastructure is the compromise of AI models as they move through the fragmented and multi-vendor pipeline. So what is the benefit of 6G? Ultra speed. It's going to be really fast. That means that multiple organizations would be able to coordinate in their cloud and various different machine learning environments at the extreme speed, almost near real time. And this multi-vendor pipeline, it's a little bit problematic. So the scenario that we have here maps this real-world red teaming exercise against an AI supply chain that is deployed in a distributed 6G orchestration. And looking here at the system architecture, so we have ORAN, intelligence controllers series. So we have edge nodes, we have centralized cloud platforms, and those models are created by third-party vendors, containerized using OCE standards, and they're deployed using real-time network functions like slicing optimizers or predictive failure monitoring. So now, here is the critical issues. Provenance controls such as model cards, SBOMs and VEX exist only in theory. In reality, these controls are partially enforced and have no cryptographic traceability, especially not at the edge. Then we move on to the threat scenario that we're building. In this section, the simulation is using a malicious actor as an infiltrator into the open source model hub of a subcontractor. So they insert a Trojanized AI model. It contains a logic bomb, which is activated under specific traffic conditions that evade anomaly detection. And what's the point? This specific bomb is bypassing anomaly detection by mimicking benign patterns, then escalates privilege laterally across the virtual run segments, and corrupts the telemetry of the to fool the AI trust scoring engine into accepting compromised behaviors as normal. And this persists, let's say we said, for weeks of the runtime model. Now, moving on to the red teaming strategy and the steps why and how those are developed. Well, first step is the supply chain mapping. So we are looking at identifying external vendors. We are looking at evaluating the CI/CD pipelines, highlighting the containerization orchestration layers, Kubernetes, for example, and pinpointing the inference endpoints. Those are industry and established vectors that we need to analyze. Then step 2, we're looking at the attack simulation design. So how did we design it? Why did we design it? Well, first is to look at, hold on, where is it? So why is it not written here? So this is the insertion point. So that is the insertion point. In literature is described as the insertion point. We're looking at poisoned models uploaded via CI hook or registry spoofing, for example. Second, this one, again, the literature is using different words than what I've used in the... second is the payload, so the backdoor triggered by edge network anomalies. And third is the propagation. So here we have the propagation that rolls out the poison containers across the edge devices. And the step 3, the risk assessment, we went through this very long table that is designed using, built using Stride tables with MITRE-ATLAS mapping for supply chain threats. And in other exercises, we're going to be looking at more. For example, in the third exercise, we might look more of those. But this is assessing the impact zones, so the inference integrity, the telemetry test, the lateral movement, and moving on to the step 4, the brainstorming. So how is this designed? Red teams are not just about finding problems, you need to test the defense. So you find the problem and you need to test if it's defensive. Although that's, you might say that's a different team, but it's part of the problem. And the mitigation strategies that you need to suggest are listed here, starting from model provenance hardenings. Here we look at blockchain, limited attestation, signed model cards, SBOMs, runtime verification, hash verification, confidential computing enclaves, zero trust for AI artifacts. So PKI backed attestation, signed telemetry, revocation protocols, or CI/CD simulations. Using red team injection during each stage, and this is automated model fuzzing for embedded anomalies. Let's look at the final step here. This is where we're looking at testing, and how can this be done in a technology that does not exist? Well, group testing is usually performed by a group of cybersecurity experts with knowledge in the field, but first you need to build the parameters based on the existing literature. This is key over here, so that's what differentiates red teaming from cybersecurity consultants. Cybersecurity consultants might be able to reproduce this very quickly based on their experience of, let's say, 5G network, because a client would pay them to do that. Clients would not pay consultants to work on 6G technology that does not exist, because there is no such. So this scenario is built around academic work, or more like a red teaming work. So in academia, you usually get paid tiny amount of money to pen test and to red team specific technologies of the future. And this is where 6G fits, because it does not exist yet. So the red team must answer specific questions. And one specific question here that we're asking is, would you trust an AI model trained externally and deployed across your own 6G pipeline? So what would it take for you to trust that? And here we have more specific answers that you would say, well, it needs to have a design of the trust framework. I'm not going to type all that now. It needs to include secure multi-party computation, federated audit trails. Where is it? Federated audit trails here. S-bombs, adversarial chaining, and it needs to include differential privacy in the training. What has been the learning of all this exercise? What you should have learned by now? You should have learned how to map a complete AI model life cycle in a multi-vendor 6G settings. So this is the complete map. So if you watch this until the end, you know how to do the mapping. You've learned how to simulate supply chain attacks using realistic threat vectors. You learn how to apply AI security risk frameworks to distributed decentralized deployments, and you know how to propose defenses that are technically feasible in a low latencies softwareized infrastructures. So we're looking at this specific problem that you have softwareized infrastructure. But this is probably enough. Let me connect the video if I can connect it quickly. Movie recording. Yeah, so that's the whole scenario that I have prepared for this. And again, this comes from existing literature with many references. On this kind of training, usually people don't really want to read the references, but the actual reason why I'm not including the references is incomplete work. I need to finish this, and probably it's going to end up in some form of conference presentation or short white paper or something. I don't know. I haven't really discovered that yet. I was trying to build the scenarios first and then see where they fit, as opposed to choose a venue and then build a scenario that fits that venue. So these scenarios are built based on the topic, and then I decide if I'm going to present this to a conference or if I'm not going to, if it's gonna end somewhere in my drive in the cloud. I'm gonna end it here, and I'm gonna start with the third scenario if I have time and willingness, because it takes a long time to describe all this.